Hi, welcome to Ms. Hobbs's class tutorial on the Work and Energy Unit, specifically the Mops 7 Energy Conservation. We're going to go over a few practice problems here to help you with Mops 7. And the first couple of problems are basically using the definitions that we found in Mops 5, where we're talking about mechanical energy, which is the overall total energy, potential energy, which is the energy of position, so either with a spring or with gravitational potential energy, and then kinetic energy, which is the energy of motion. So basically anything that's not gravitational or spring energy or spring motion or springs is kinetic energy. So one of the problems that difficult questions that you're probably going to have on MOP 7 is an object starts at rest from a height of 40 meters, and a total amount of mechanical energy is 400 joules. The object begins a free-falling motion. There is no air resistance. When it has fallen to a height of 1/4 its original height, its potential energy will be blank, and its total amount of mechanical energy will be blank joules. Enter the two answers in their respective order with no commas or spaces between the letters. So the first step that you're going to need to do is you're going to need to find out what the total energy in the system is. And what you're going to do is take that 400 joules and write that down. That's the total energy in the system. And that's going to equal the amount of potential energy plus the amount of kinetic energy. So the amount of potential energy plus the amount of kinetic energy. You're going to need to write this down because my pen doesn't work. So when it has fallen to 1/4 of the original height, you can find out the potential energy. So 1/4 of the original height is 10 meters. So to find the potential energy at that height, you're going to take 10 meters times 10 meters per second squared, which is the acceleration due to gravity, times the mass. And it doesn't really matter what the mass is because the mass will cancel out on both of them. Okay? So that'll be the total mechanical energy or total potential energy. Then we know that the potential energy is going to be equal to the the total energy will be equal to the potential energy plus the kinetic energy. So what you need to do is take the total amount of energy, subtract that from the potential energy that is still there, and that's going to equal the amount of kinetic energy there. Okay? And that will be able for you to find the kinetic energy, the potential energy, and then the total mechanical energy. In other words, the total mechanical energy will stay the same no matter what. The potential energy will decrease, and if it asks you what the kinetic energy is, the kinetic energy is going to increase in an equal amount to complement the potential energy decrease. Okay? All right. The next question that you're probably going to have is something like this. And we've got a hill that's kind of cut off a little bit, but we've got a slider on position A and a slider on position E. And basically it's testing your knowledge of energy conservation. It says a slider effortlessly glides from position A, from the snow, position B. Resistance forces are negligible. At position B, the total mechanical energy of the slider is blank, and the kinetic energy is blank. Enter the two answers in their respective order. So in other words, the total mechanical energy is adding position A together. That's the total mechanical energy. And if energy is conserved, the kinetic energy in position B is going to be equal to, the mechanical energy is going to be equal to the kinetic energy plus the potential energy. So this is 10,000. So this is going to be, again, the total is going to be 10,000. So the kinetic energy will be 6,000. And this is going to use the same principles. So you've got a few different numbers, and it may ask the different kinetic energy versus mechanical energy, but you're going to use the same system there. Here's the doozy. Two objects of identical mass begin from the rest at the same height at the top of two different hills, hill A and hill B. The hills are inclined at two different angles. The objects are released from rest and slide to the bottom. Resistance forces can be considered negligible. So in other words, we're working within an energy conservation model. The object on the top of the hill will have the greatest speed at the bottom of the hill. And so it's hill A or hill B. And they're wanting to see if you're going to have the greatest speed. Now, here's the deal. Most people are going to think that it's going to be hill A, okay? That's not true because they have the same amount of potential energy. So they're going to have the same amount of kinetic energy at the bottom. Also, the mass of the ball doesn't change, okay? So when we're talking about comparing kinetic energy at the bottom to kinetic energy in the bottom, the mass doesn't change, the amount of energy doesn't change. So even though you think the velocity would change just based on your intuition, it's not going to, okay? So we've been talking about energy conservation. Remember that mechanical energy is the total amount of energy in the system, and the potential and the kinetic energy balance each other out. Please put a comment in the comments section and let me know if this was helpful, if I need to, for example, write on the problems, or if the verbal explanation is enough. Thank you.